All right, so in this video, we're trying to solve for x in the following equation, where b, a, and x are matrices. And to start out, I think we should simplify the left side. And so we can go ahead and we can distribute this inverse in. And if we remember the fact that the inverse of a scalar here would be 1 over 4, let me write it smaller here, 1 over 4, times the inverse of b inverse x. We have the fact that here, a, b, where a and b are arbitrary, minus 1, or to the minus 1, is b inverse, a inverse. So these flip, and then we take their inverse. So remembering that fact, we can go ahead and we can write this as x to the minus 1 times b. And so this left side becomes x 1/4 x inverse times b to the right. And so we can go ahead. We can use the same logic here. Let's simplify this part here. We can write that as pretty simply 1 to the well, I'll just write it without these. Sorry, 1 over a third a minus to the inverse multiplied by b, all that inverse, ba to the 3. And this is a lot simpler, but we can go ahead. We can do the exact same thing that we did here, or here, to this point here. So now we have all this is equal to the inverse of this, which we inverse a scalar first, so we get 3, and we flip these two, so we get b inverse times a, because the inverses cancel, now times b times a cubed, and all that is of course equal to 1/4 x inverse times b. Great. Now we can go ahead. I mean, we can get rid of the scalar here. We can multiply both sides by 4, so we get 4 times 3 times, here we have 4. These 4 strike out. So now our new equation is, is x to the minus 1, b equals 12, b inverse a, b, a, 3. How do we get rid of this b here? Well, we right multiply, so we multiply both sides by the inverse of b, and then that would cancel out. So now we get x inverse equals 12, b inverse ab, a cubed, b inverse. Great, but we don't want to solve for x inverse, we want to solve for x. So we can take this whole entire thing, the sides of the thing, and raise them all to the inverse here. So doing that, we get that x is equal to the inverse of 12, the inverse of this entire thing here. So x is equal to this thing here. So that's not great. So let's go ahead and write that out. First of all, we have, so 12b minus 1. Let's get rid of the scalar here. We have 1 over 12. And now we have this entire section right here that we have to inverse. And what I said earlier, where AB inverse is equal to B inverse times A inverse, that actually applies pretty generally. So we can use this fact here. If we go ahead, we can write the matrices that if you have a whole bunch of matrices being multiplied, and you try to take their inverse, that is equal to essentially the reversal of all of them minus a capital N, minus k. So you're just kind of reversing all their orders, and inverting them. So using this here, we can see, okay, we get B, this B comes in front, we take its inverse, so we get B, then we get a to the minus 3, which is just A inverse times A inverse times A inverse. And then the B is in the middle, but that goes ahead, we invert it, we invert the A again, and then we just take the positive B. And all of a sudden, we get an answer like this, and it doesn't really look great, but, right, this is our solution. X is equal to 1 over 12, B, A to the minus 3, B inverse, A inverse, B. And so hopefully this was helpful. Linear algebra is just all about remembering, factoids like this to maintain equivalency but simplification at the same time. So if you have any other questions, feel free to ask them, and I will see you in the next video.